We have another problem where the unknown is the index of the radical. And again, it's index of the radical. Index of the radical is also part of the radicand on the right-hand side. So let's look at an example of what we mean to have a variable index. Let's say we have the x root of the constant 5. Okay, that's absolutely equivalent. Now, it's kind of superfluous to put the 1 here, but we will for the exponent. This means the very same thing using rational exponents as 5 raised to the 1 over x power. Okay, so we're going to shift to rational exponents because it's just more convenient, in my opinion, to work the problem that way. So you can write down the given problem equivalently as this: 64 raised to the 1 over x equals to x over 12 to the 1 over x to the 6. And this is the part that's slightly dicey here. This is pretty normal over here. This is all normal looking stuff, but we have a fractional variable dependent index on the right hand side. All right, and so let's carry on. So again, the given problem is equivalent to this. Now, when you invert and multiply here, 1 divided by a fraction is the fraction reciprocated or inverted. We get this statement, okay? Now, how is it that we're going to get rid of this x? Well, just a standard property of exponents. If we raise both sides to the x power, we multiply the exponents. It's a very well-known property of exponents. And of course, eliminating the variable x here, or most of the occurrences of the variable x is going to be towards a solution here. So what happens here is this just ends up being 1 over x times x. We're assuming x isn't 0, and x equals 0 is not a solution to the original problem. Doesn't make any sense in the original problem. But what we end up with is the constant 64, which is always an ideal to be strived for. Get a constant somewhere on one side of the equation. It's usually easier to work the problem. And then right here we have equals 2. This x cancels with this x when you multiply the exponents, and we get x over 12 quantity raised to the 6th power. Now this is an example. Okay, if you take a look here, this is going to be raised to the 6th power. Sorry. Yeah, this x cancels with this x. Now, what sort of approaches should we adopt right here? Well, we know, let's look what the left-hand side is equal to. The left-hand side is equal to 2 raised to the 6th power, right? So this forces x over 12 to be 2. In other words, this 2 base right here forces x over 12 to be 2. So let's write x over 12. Has to equal to 2. Right? And that's clear, right? Because you see, you have the same exponents right here. Exponent 6 here, exponent 6 here. So we have no choice but to equate the bases here. And the bases are 2 and this variable base x over 12. And of course, this implies that x is equal to 24. Now, we haven't done anything wrong, so but it's probably important to go back and check the original problem. So we're getting x equals 24 as our posited solution. Now notice right here, a way to see that this is true is that, I'll just write it right over here, 2 to the 6th can be rewritten, right? That's equal to 2 raised to the 1/4 power raised to the 24th power. Not something you would have necessarily noticed by inspection at the beginning of the problem, okay? So this is proof that this holds, and we'll go ahead and recopy the answer. X is equal to 24. Okay, thank you for viewing.